Hello everyone and welcome. In this video we want to solve the following problem. Give all possible representations of 2022 as a sum of at least two consecutive positive integers and prove that these are the only representations. Now you can pause the video and try to solve the problem, then post your answer in a comment. Otherwise, let's get started. Now, first of all, we're going to introduce a notation. So we're going to denote by n the number of terms and by a the smallest term in such a representation of 2022. Now, the problem can be reduced to solving the following equation for n for the ordered pair NA. Now, let me remind that n and a are positive integers and n is greater than or equal to 2 because n is the counting number. It counts how many numbers we're adding. And a is the smallest number among all our consecutive numbers. Now, the equation can be written in a more compact form as the sum as k goes from 0 to n minus 1 of a plus k equals 2022. Now, some observations are in order. The first observation is that we cannot add an odd number of odd terms in our sum because otherwise the sum will end up to be odd. But 2022 is even, so that's not possible. We always have an even number of odd terms in the sum. So in particular, this means that we cannot write 2022 as a sum of two consecutive terms. Why? Because if we have two consecutive integers, one of them is going to be odd and the other one is going to be even. So the sum is always odd. So consequently, we can say that whenever we have a sum, a representation of 2022 as a sum of consecutive positive integers, that sum contains at least 3 terms. Okay, so in terms of the notation we adopted at the beginning, this means that n is always greater than or equal to 3. So this is going to be useful later on. Now let's go back to the equation. So we can simplify the left-hand side simply by using properties of sums as follows. And then, because a is a constant, we can have n times a plus n times n minus 1 over 2 equals 2022. Now we multiply everything by 2. And what do we get? We get 2na plus n times n minus 1 equals 4044. Now we can factor out n on the left-hand side. If we factor out n, we get n times 2a plus n minus 1 equals 4044. Now notice that on the left-hand side, we have a product of two terms. And on the right-hand side, we have a number. So we have to write that number as a product of two terms. And we have to consider all the possibilities. And those two terms must be positive integers because n is an integer and 2a plus n minus 1 is also an integer. So in order to do that, we have to know the prime factorization of 4044, which of course is given by 2 squared times 3 times 337. So this tells us that 4044 can be written as 1 times 4044, or as 2 times 2022, or as 3 times 1348, or as 4 times 1011, or as 6 times 674, or as 12 times 337. Now, of course, because multiplication is commutative, we can interchange the order of multiplication. So that's going to give us another set of possibilities. So now we can say that we have either n, 2a plus n minus 1 equals the following set of ordered pairs, or it's going to be the second set of ordered pairs. Now let's examine the first set of ordered pairs. In the first set of ordered pairs, we see that n is always greater than 2a plus n minus 1. Now, because n is always greater than 2a plus n minus 1, if we subtract n minus 1 from 2a plus n minus 1, we always end up with a negative a. But a is actually a positive integer, so that's not possible. That's why we have to exclude these sets, this set of ordered pairs. So now we only have the second set of ordered pairs remaining. So the second set of ordered pairs is given by 1 and 4044, 2 and 2022, 3 and 1348, 4 and 1011, 6 and 674, and 12 and 337. Now, remember that n is greater than or equal to 3. So we can drop the first and second ordered pairs. So we just delay those. So we only have the last 4 ordered pairs. Next, what we're going to do, we want to solve for the second coordinate. We want to solve for a. So in order to solve for a, we already know the value of n. And it is equal to either 3, 4, 6, and 12. So subtracting n minus 1 from the second coordinate, for instance, for the first ordered pair, n is equal to 3, so n minus 1 will be 2. So we want to subtract 2 from 1348, and so on. So if we do that, we get the following. And after simplifying, we get that n, 2a admits the following values. Now, we have a value that does not belong here. It's this value here, 669. It's an odd value, but 2a is even, so we can drop that one. So let's drop it. I'm just going to delete it. So we only have 3 possibilities left. Then we can divide by 2. After dividing by 2, we get that n, a equal 3, 673, or 4, 504, or 12, 163. So those are the possibilities we have left. And there's no other possibility. So this actually proves, in the meantime, that these are the only possibilities. These are the only representations we can have. Okay, now let's see the representation of 2022. Now, the first case is when n, a is equal to 3, 637, 73, sorry. So 673 is the first number, and we have 3 numbers in the sum. So the next one is going to be 674, and the last one is going to be 675. Now we just need to add up all those numbers, so all those 3 numbers. And of course, by adding those 3, we get exactly 2022. Next, we have the case where n, a equals 4 and 504. Of course, we have 4 numbers here. Those numbers are going to be 504, 505, 506, and 507. So if we add those four numbers, we get exactly 2022. You can check that with a calculator. And finally, the last case is when NA is equal to 12 and 163. So the first number is going to be 163. The last number is going to be 163 plus 12 minus 1, which is 174. So if we add all those numbers, so from 163 to 174, we always increase by 1, and we get exactly 2022. Okay, I think this is a good place to stop. I'll see you next time. Bye-bye.